versus about 3% of males in the general population. And if you have this severe disinhibited condition, while it only explains a relatively small proportion of alcoholics, what you're inheriting is an increased predisposition towards gambling, an increased predisposition toward violence, an increased predisposition toward dependence on every drug you can think of, not just alcohol. So the risk for alcohol dependence is not only hard to study because environment is explaining almost half the picture. The risk for alcohol dependence is very hard to study because there are a variety of different things that are inherited to increase or decrease the risk. And in only some of the families, what's being inherited is disinhibition, impulsivity, sensation seeking. It's all kind of put together into a ball. And these people have an increased risk for every kind of drug dependence and for other problems, such as violence. There are other things that are being inherited that impact on the alcoholism risk that actually help protect you, at least if you're Asian. They don't have much effect on individuals who aren't Japanese, Chinese, and Korean. But about 40 to 50% of Japanese, Chinese, or Korean individuals inherit a way that they metabolize or break down alcohol that gives them either a very intense bad reaction to alcohol, that's true of about 10%, or gives them not a terrible reaction, but gives them a more intense reaction, so they tend to drink less. When they drink, they tend to consume less. And that is through the genes that control the enzymes that break down the alcohol. Here, what people are inheriting, at least among almost half of Japanese, Chinese, and Korean families, here what people are inheriting has nothing to do with their risk for impulsivity, gambling, violence, nothing at all. Has nothing at all to do with their risk for heroin dependence or marijuana dependence or amphetamine dependence. What they're inheriting is a protective factor that applies only to alcohol dependence. The point here, alcohol dependence is genetically influenced. It's got to be. Runs in families. The twin studies show it's genetically influenced. And the adoption studies show that kids of alcoholics have a high risk no matter who raises them. But that all of the genes together are only explaining about 60% of the picture. And that 60% isn't one characteristic. It's a variety of characteristics that are impacting on your alcoholism risk. Just like in the risk for heart attacks, not every family is carrying the same risk factor. A variety of risk factors that differ in different families. So what we got to do is look at one of the risk factors that I'm going to talk about, which will be the level of response to alcohol. I'll define that for you in a minute. It's one of the additional things that impact on your alcoholism risk. Basically, are you a cheap drunk or an expensive drunk? And if you are a cheap drunk, that is, you're pretty sensitive to alcohol, you probably have, not probably, you have a lower risk for alcoholism. And if from early on in your drinking career, you can drink almost anyone else under the table, from almost the first time that you start drinking, you are carrying a very high risk factor for alcoholism, and I'm abbreviating that as the level of response to alcohol. And I'm going to talk today about how I take another risk factor that has nothing to do with metabolism, nothing to do with disinhibition or any of the other risk factors that I had on the other slide, and it is related to the family history of alcoholism, level of response to alcohol. It does predict alcoholism directly, but it also relates to things like your expectations of how alcohol is going to affect you, whether you choose heavy drinking or light drinking friends, how you cope with stress and whether you use alcohol to cope with stress. Genes, environment, together explaining the picture of how a particular genetically influenced characteristic increases the risk. Now, if I ever want to get to the point that I can understand how somebody carrying a particular gene might be able to be helped to prevent their risk for alcoholism, I'm going to have to look at specific genes and see how those specific genes relate to other factors like drinking and the environment, attitudes towards alcohol, or expectations of the effects of alcohol or the use of alcohol to cope. You've learned thus far alcohol dependence is genetically influenced, Environment is also important, and that there are a variety of risk factors that could increase or decrease your risk. And I've introduced you to the concept that how you respond to the alcohol from early on is both genetically influenced and relates to your alcoholism risk, and that I'm going to search for both the genes and the environmental effects in order to try to put together prevention approaches, which allows us now to go on to what is this thing, level of response to alcohol? How am I going to search for genes related to it? And how might that impact on prevention and treatment? In effect, you can define a low response to alcohol or the need for more alcohol to get an effect from very early in your drinking career two ways. One way you can do it, you can give a bunch of people who you think might be at high risk and who are not alcoholic yet. You can give them alcohol and observe how they react and see whether the people who are at high risk for future alcohol problems is defined, let's say, by their family history, or defined by being a Native American of a particular tribe with a high risk for alcoholism. You can say, are these people who we know are at high risk for alcohol in general also characterized by a low response to alcohol? Give them the booze and they don't have much effect. Of course, there's another way to do it. And the other way to do it is to give them a questionnaire and say, tell me, early in your drinking career, how many drinks did it take to have various effects? And I'm going to show you that we in our research have done both ways. So, for example, we have taken non-alcoholic but drinking 20-year-old sons and daughters of alcoholics. They're at high risk for future alcoholism. Given them alcohol at the beginning of the experiment, and then measured their subjective feelings. Subjective feelings, 120 or 150. It's a test that we particularly use. They're telling us, whoa, my God, am I feeling a lot? Or closer to 40, I'm not feeling all that much. Everybody's got the same blood alcohol level. And what we find is, in fact, that the children of alcoholics, sons or daughters, in general, are showing less response than the children of non-alcoholics. These are just the statistical tests to show that especially 30 minutes after drinking, 60 minutes after drinking, and 90 minutes after drinking, there's a huge difference remains throughout the rest of the experiment as well. So we have data that show that about 40%, it's an interesting figure, of the sons and daughters of alcoholics are pretty low responders to alcohol at a given blood alcohol level, compared to children of non-alcoholics. And for children of non-alcoholics, less than 10% show this low response to alcohol. When we take and we ask people to remember back to the number of drinks the first 5 times that they drank, and this is in other experiments that we've done, and we say, okay, back to the first 5 times you drank, and I'm going to define a drink for you. 12 ounces of beer, 4 ounces of wine, or a single shot. How many drinks did it take for you to first feel an effect, the first 5, 10 times you drank? For me, a half a beer, maybe at most a full beer, but I can still feel the effects of a half a beer. And then how many to feel dizzy or to slur your speech? For me, 1 to 2. How many before you would guess that you would have enough that you would be stumbling? For me, 4. But children of alcoholics in general are reporting to first feel an effect, 2 to 3. To first feel dizzy, maybe 6. To stumble or lose your balance, maybe 8. So they report more drinks for an effect, which correlates very highly with test them with the alcohol, and you find that they have less effect per drink. Same thing. So I've used this self-report measure of the effects of alcohol and used alcohol challenges to try to look at a variety of populations at risk for alcoholism, and I've collaborated with other people who have looked as well. And generally what we find is you come from a group with high risk for alcoholism, you're very likely to report you need more drinks to have an effect, or if you're in one of the groups that we test, that at a particular blood alcohol level, there ain't very much effect. So the level of response to alcohol relates to the alcoholism risk, and the level of response to alcohol, genes explain about half. This figure heritability, it doesn't matter very much. It comes from twin studies, and it comes from studies of multiple generations and families. And you can use these studies to come up with an estimate of a person's level of response to alcohol, how much is genes and how much is environment. About half is genes, about half is environment, about the same as you get for alcoholism overall. Now, instead of looking at alcoholism, we're saying, let's break alcoholism into what specifically you're carrying that's impacting your risk. Level of response to alcohol is about half genes and half environment. And the level of response to alcohol is low in children of alcoholics. It is low in Native Americans. That's a study done by Cindy Ellers here in San Diego. Among Asians, it tends to be low response to alcohol. You need a lot of booze for an effect. Among Koreans compared to Japanese and Chinese. And Koreans have the highest risk for alcoholism among those three groups. And we have a small study of Jews. Jews have a low risk for alcoholism, not totally zero, but lower than the general population. And the studies that we've done, Jews are more sensitive to the effects of alcohol. So we've got in children of alcoholics, Native Americans, Koreans, and Jewish subjects, the risk for alcoholism in general, not perfectly, relates to level of response to alcohol. Doesn't explain everything, probably only explains part of the picture, but it is consistent across various groups. And there are 4 follow-ups that have looked at people and said, okay, about age 20, we're going to test you and look at your level of response to alcohol. All 4 used actual alcohol. And they could characterize people, more change, less change with alcohol. And then 5 to 20 years later, our work is 10, 15, and 20 years later. 5 to 20 years later, follow people up and say, okay, this interviewer knows nothing about your response to alcohol from before. Let's try and gather a history from you and from your wife or husband about you. Let's try and gather a history of your levels of problems for alcohol that have occurred recently. And all 4 studies show low responders at about age 20 show a high risk for severe problems, alcohol abuse and alcohol dependence at about age 30, 35, and 40. So, alcoholism is genetically influenced. One of the factors that's strongly genetically influenced that impacts on the alcoholism risk, how intensely you respond to alcohol. That factor, the level of response to alcohol, is itself genetically influenced, is related to your risk. That is, children of alcoholics show a low response to alcohol and predicts alcoholism in the future. From my work and from others, I know that the level of response to alcohol is a good place to begin to study individuals to try to find the genes relating to low response as risk factors for alcoholism. And I put together a study, the San Diego Prospective Study, that began in 1975 and has followed subjects up, initially when they were 20, and then followed them up at 30, 35, and 40, so I can evaluate in the original subjects, not only did they develop alcoholism, not only what was their response to alcohol, but I can look for genes related to the low response. And I can do that while studying the environmental events, or at least things other than the level of response, including such things as their expectations of the effects of alcohol, whether they use alcohol to cope, the amount of drinking among peers. And this study basically has 437 of the 453 original subjects. 4 of the original subjects have died, so that leaves only 449 remaining. And out of the 449, we have data at all follow-up points on 97%. Then these guys had 335 first spouses, and if we had it on the slide, they've actually had a total of 365 spouses, and they entered the study. And we get to follow them over time, looking at their response to alcohol by their self-report measure, and there are 553 offspring. And these people they're interviewed every 5 years, and a variety of questionnaires regarding things going on in their environment. So how do I take the San Diego Prospective Study, about 440 guys followed up for 20 years, their 365 spouses, and their 553 kids, and how do I put them together in a study that, as if this were a roadmap or branches of a tree, I put them together in a study where I can both search for genes through this and other studies, and in the San Diego prospective study at the same time try to find the environmental effects that are relating to the genes that are impacting on the level of response to alcohol. Let's take a look at first how we're searching for genes. Before I do that, let me fill you in on why I should care about the genes. When people talk about genes in healthcare delivery, most of us, and I do the same, jump to the conclusion, oh, they're going to look to do gene therapy. Only going to do gene therapy for the diseases caused by genes, like cystic fibrosis. If the gene isn't 100% responsible for the gene, you can't mess with it without causing a lot of troubles. So only if it's a deadly disease for which genes are responsible for 100%, forget gene therapy. For most disorders, however, where genes are just contributing, the importance of finding the genes is to say, oh, I can now study people from relatively early in life, maybe in the San Diego prospective study, and I can say, if I know what the gene is that's impacting on the risk, let me look at the things in the environment that seem to relate mostly to that specific gene. For example, if there were a gene relating to the level of response to alcohol that was associated with something known to make you feel, boy, I feel laid back and really good, then that gene probably will impact more than any other way through your expectations of the effects of alcohol and whether you use alcohol in order to cope with stress. But if there's another gene that really relates to, in a mild way, whether you're easily bored and a little more sensation-seeking, then that gene is probably going to relate through personality characteristics as opposed to, boy, I think that drug really is wonderful. And so the specific things that you're likely to mess with in the environment depend upon which gene's important. So searching for genes is a clue as to, for an individual, which approach to prevention is more likely to be more effective and less effective. There are two classical ways to search for genes, and I'm going to leave the animals out of this. The two classical ways to look for genes, no matter what disorder you're looking at, is called association or linkage. Let me first talk about association studies. And association studies are also called candidate gene studies. Here what you do is you put on your thinking cap before you start the study. And you say, before I do these analyses at least, I want to guess what genes might be involved. And I'm going to do that by looking at animal studies and by using my common sense. Then I'm going to take people who, for example, have a really low response to alcohol and people who are similar in every way possible but have a high response to alcohol. And I'm going to say, is this particular gene more often seen in the people with low response than in the people with high response? I've picked a candidate, a gene, and I've looked at people who have my characteristic and don't have my characteristic and said, is it different, the rate of the gene in the people with and without the characteristic? And there are a bunch of things that I'm looking at. One of them is something called GABA, G-A-B-A. And GABA is a brain chemical that makes you feel laid back when it's turned on. GABA is pretty much what the Valium-type drugs affect. It's pretty much what the anticonvulsant drugs affect. And whoa, does alcohol have a huge effect on GABA. So we came up with, from the animal literature, a particular form of GABA, which is called the GABA-A alpha-6 receptor, that in animals make them resistant to the effects of alcohol and also makes them resistant to the effects of some other drugs as well. And we said, let's look at people with high response and low response and see whether they're different in their forms of GABA. There's another neurotransmitter, abbreviated as 5-HT, which is serotonin. It's a brain chemical. And we guess that the serotonin might be tied in mostly through personality. You drop somebody's serotonin really low, And a variety of things happen, but one of them is they get real irritable. And it's thought that some people may have, it's an oversimplification, lower levels of serotonin, which make them a little more boredom susceptible and a little more sensation seeking, and we would guess that the level of response to alcohol might be related to a specific form of something related to serotonin. So we tested that. Let's take a look at this brain chemical GABA. Here's a form of the receptor for this brain chemical that should have been related to a relatively low response to alcohol. This is all relative to other people, and indeed, if they have this form of the gene, they have a low response to alcohol, -1, rather than about -0.3 for the people with the other form of the gene. And in this study, small study, only 50 people, clearly low, clearly high responders to alcohol. In this study, if they had this particular form of the gene, 70% of them were alcoholic, which was almost 4-fold higher than the people with the other form of the gene. Got a candidate, got 2 forms of the candidate, looked to see whether the level of response related to the forms of the candidate. It did, and went and looked at whether it related to the alcoholism risk. It did as well. We have another neurochemical, that serotonin-related gene. There's a form of that serotonin-related gene that should have been related to a low response. So this is relatively low response to alcohol, -0.9, versus pretty neutral for people with the other form of the gene, with a rate of alcoholism that's much higher, 60% versus 12% for people, 5-fold difference with the other form of the gene. And then it turned out 4 people had both the active forms of the gene that I was interested in. They had a real low response to alcohol, and all were alcoholic. How do you look for genes? One way to look for genes is to try to take people who you have been able to characterize on what you're looking at, pick a particular form of the gene, and say it does or does not relate to the characteristic you want. So we've got 2 candidates that we looked at, and both candidates relate to the level of response to alcohol in the way that we predicted. Now there's a second way of looking at genes, and all that this is telling you is there's another study that I'm involved in called the Collaborative Study on the Genetics of Alcoholism, abbreviated as COGA. And here we use the other classical approach. What one does here is say, oh, God, I don't know what genes to look at, but I do know that I have whole bunches of people, and here there were really basically almost 1,500 people as part of the study. And I measured their response to alcohol based on this self-report measure, and then I used a computer to tell me, was there any particular chromosome, chromosomes are made up of genes, or area of a chromosome, and the area might have 100 genes in it. Is there any particular chromosome or area of a chromosome that appears to be tied to the level of response to alcohol? I also did this in another study done jointly with people from the Gallo Institute at the University of California, San Francisco. And from those 2 studies, I'm able to put together areas of particular chromosomes, like chromosome 2 at a particular location, that showed up related to the level of response to alcohol and to alcoholism and to other markers that might be interesting. Then another on chromosome 7 that showed up both on alcohol challenges and on the self-report measure and related to alcoholism. Once we find a chromosomal region, then look to see, are there any genes that might logically be related to the alcoholism risk or to the level of response to alcohol, and go back and test them as candidates. I've deliberately kept the information on genetics relatively brief, and let me summarize for you what is important. Once we know a disorder like level of response to alcohol, or a disorder like alcoholism is genetically influenced, and know a characteristic level of response that related, we can start looking for genes. And we look for genes either by picking candidates that we think might be related to the characteristic, or by saying, don't have a clue about candidates, and allow a computer to tell us what areas of what chromosomes might be related, and then we start looking at specific genes. But in any event, for a disorder like alcoholism, and a characteristic like the level of response to alcohol, for this kind of characteristic, finding the genes is just part of the challenge. And finding the genes on their own accomplish almost nothing. So what one has to do is say, well, the development of alcohol dependence or dependence on any other drug really isn't just one bad thing that occurs. It's actually a series of dominoes, and at least half those dominoes are environmental. So how do I now start searching for the environmental factors with which those genes are likely to relate in order to be able to put together prevention approaches? And I'm going to come back to the San Diego prospective study where I'm looking at people over time, and I'm going to look at things both in the original subjects and in their 553 kids. For example, we've got these guys, these 440 remaining subjects that we evaluated at 20, 30, 35, 40. And when we evaluate them, we're not only looking at whether the level of response predicted alcoholism or other problems, but we're also measuring things in their environment, such things as, do they have a lot of life stress? And such things as, how do they cope with stress, for example? Do they use alcohol to cope with stress? Such things as, are they a little easily bored and a little bit more sensation-seeking? That's behavioral under control. What kind of nurturance do they have in their social support system? What kind of attitudes do they have towards the effects of alcohol, alcohol expectancies? How much drinking in their environment? And as we look at these, in the parent, we can look from birth on, especially from age 7 on, where kids are starting to get out of the home. We can look at the same things in the kids. So in the kids, we can look at levels of life stress, drinking among peers, level of social support, especially in the home environment, expectations of the effects of alcohol, how they use alcohol to cope, especially once the kids, obviously, are old enough that they report to us that they've had some experience with alcohol, and they can tell us on the self-report measure their level of response to alcohol. And we plug these all into a model for both the original subjects and the kids. And we look at, well, how does the level of response, now, for example, defined by that GABA gene, relate to drinking in the environment, expectations of the effects of alcohol, coping, and all those other things that I was telling you about. And our goal is to try to understand more by placing the gene into the model, to look how, there's a G here, how the gene relates to the environment, gene-environment relationships. And everything I've been telling you up till now is to build up to this punchline. If alcoholism is genetically influenced, but genes explain only part of the picture, if I study the environment and study the genes in the same people, maybe I can start putting together prevention and maybe even treatment approaches that make more sense for what an individual needs. I'm going to especially be interested in what's called gene-environment interactions. So let's take the level of response to alcohol, which I showed you on the other slides, relates to your alcoholism risk. But instead of level of response, I'm going to look at a specific gene. Let me take something else in the environment that I know relates to the alcoholism risk and test statistically whether the two interact. And I'm going to show you what that means. But an example of interaction is, let's say that the gene, the GABA-related gene, predicts alcoholism, and let's say that the expectations of, whoa, that's going to make me feel great, relate to the alcoholism risk. Maybe the gene only operates in increasing the alcoholism risk if you've got fairly solid expectations of the effects of alcohol. If you say, I don't care, alcohol doesn't do much for me, then the gene is irrelevant. So that would mean the gene might only work when the other environmental event is operating at a high level. And when the other event is operating at a low level, the gene doesn't have any impact at all, which would imply that change the environmental event. And for people with low levels of response to alcohol, you might be able to decrease the chance they're going to get into trouble with alcohol if they choose to drink whenever they feel like it. Let's look at the expectations of the effects of alcohol as it relates to this GABA-related gene. If the expectations of the effects of alcohol are relatively low, alcohol doesn't do a lot for me, there's not much correlation between that gene and an alcoholic outcome. If, however, somebody says, oh boy, I really like drinking, it really has a major impact on, especially what we're looking at is, when I drink, it gives me this wonderful laid-back feeling, then in fact, the low level of response to alcohol, now substituting the GABA gene, is strongly correlated with an alcoholic outcome. Same thing with whether one uses alcohol to cope. GABA A alpha 6, this particular form of the gene, overall predicts alcoholism, but especially if people say, yeah, you know, I've had a bad day, I tend to use alcohol. It really has a very high effect. The serotonin-related gene doesn't relate at all to alcohol expectations or whether they use alcohol to cope, but has a huge amount to deal with how they deal with boredom. So if they get pretty easily bored, then the relationship between that other gene and the alcoholic outcome is high. If they pretty much don't get bored easily and they know how to handle their boredom, it doesn't work at all. So I can show you this pretty much graphically as well. The GABA-related gene predicts alcoholism pretty well, but most of that is occurring in people who are using alcohol to cope with stress. Most of the GABA-related gene is also occurring in people who have pretty positive expectations regarding being laid back when they drink. Most of the serotonin-related gene as the explanation of level of response to alcohol only really, it operates pretty well overall, but really what's happening, it's only relating well when people are pretty easily bored. It's called externalizing. Pretty easily bored and a little bit sensation-seeking. Let me review what this lecture has tried to cover for you. I want to give you a little bit of some thoughts and a little bit of background. And then I want to tell you what the implications of what I'm talking about are. Let me give you a little bit of background first. I could have given you a lecture on genetics of alcoholism that would have brought you pretty much up to date to where the field is that was much simpler 10 years ago. 10 years ago, hey, I could have just focused on background. Let's take 20 years ago. I could have just concentrated on background. Alcoholism is genetically influenced. It's genes plus environment. It's really complicated. Probably 20 years ago, I certainly 20 years ago had put together this model where the level of response to alcohol interacts with the environment. But it wasn't until we carried out this prospective study, started to actually look for genes and look for the environment, that we could finally get to the point that we could make some guesses, and now we're going to have to try to find out whether our original data are going to hold with additional studies, that we could make some guesses as to what in the environment one has to change based on the genetic background of the person. But it gets complicated. And in putting this lecture together, I really debated. You all are people who work mostly in the clinical field of alcohol and drug dependence. I debated, do you want just the punchline? Yeah, alcoholism is genetically influenced and it's complicated. One of the things that's inherited is how you respond to alcohol. Or would it do you any good for your practices to be able to go on and understand a bit more about, no, this kind of stuff really in the future might impact on how I prevent and how I treat. And in the meantime, these are the kinds of things that I might be able to borrow from and modify and help teach my patients, clients, and their families. So let's take a look at how the material that I presented helps us all, carrying those of us who are wearing clinical hats, to go through the next door of the implications for prevention and treatment. Let's deal with prevention first. What I'm hoping to be able to do is to say, hey, up till very recently, I know if you have a family history of alcoholism, you're at fourfold increased risk for alcoholism. And I know that it makes sense to tell you not to drink. And if you choose to drink, it makes sense to tell you to drink really carefully. Now I can go a bit further. Perhaps. I'm not ready to do it yet. It'll depend upon whether our original findings that we just recently analyzed hold up in future research. Now I can say, okay, theoretically, if this holds up, let me do a blood test. The blood test is going to tell me whether you're carrying any of the genes that we've studied thus far that relate to the level of response to alcohol to enhance your risk. And I can now say, basically, it's time to do a research project, and not too long from now to actually do some clinical implications of this. If you're carrying that GABA gene, I'm going to have to work with you that if you choose to be a drinker, you're going to have to focus very carefully on what you want and what you expect from an alcohol session. And you're going to have to modify your expectations, or you're really going to increase your risk for alcoholism. If you're carrying that GABA gene, it's not a bad thing to do what I'm about to say with anybody, but especially if you're carrying that GABA-related gene, man, you and I got to start working on how do you identify when you're feeling stressed out? What options do you have to deal with your stress? And for God's sakes, put at the top of the list, my first option for dealing with stress is to not drink, because it's going to make matters worse. That's good information for anybody, but these people with that gene, if the research holds up, are particularly vulnerable. And yet, if I was dealing with somebody and found out that they had this particular serotonin-related gene that I'm interested in, if I was dealing with those individuals, I would, sure, why not, teach them a little bit about expectations, but according to these data, probably not going to have much impact on their alcoholism risk. But them, I got to start dealing with, you know, you probably, by the history that I'm likely to get, fairly easily get bored and sometimes wonder how to handle your boredom. Well, I'm going to have to help you deal with recognizing when the boredom occurs and looking for alternate ways to try to deal with that feeling of frustration and kind of life isn't all that interesting when you're getting bored. But God help you if you use alcohol in that kind of a situation. So the more genes I can understand as they relate to level of response to alcohol, the more I'm going to be able to test in that gene to substitute for level of response, particular environmental event, to look for things that might be interacting, with the hopes that I can put together more and more sophisticated ways of teaching about prevention. Well, what about treatment? This is a little iffier, but I think that this is probably going to come to pass as well. If I can understand more about how a particular individual was predisposed toward alcoholism, even if I catch them after the alcoholism is there, I should be able to put together a treatment approach that might have a greater impact on them than anyone else who has alcoholism. And my guess is that this is particularly likely regarding treatment to relate to treatments. So let me go off on a little bit of a tangent here about the pharmacological or drug-related treatment of alcoholism. So a brief aside, then I'm going to come back to where the kinds of things I'm studying could fit in. Right now, the major mainstay of alcohol treatment is change how people view alcohol, view what's going on in their life, use alcohol to deal with what's going on in life. It's a cognitive behavioral approach. And that's pretty much what Alcoholics Anonymous does, and that's pretty much what most formal treatment programs do. And right now, for alcoholism, there are several medications that might be